Okay, good morning. I'm Sriram Narayan. I've been with ThoughtWorks for some time now, about 6.5 years. And I'm somewhat interested in service-oriented architectures, and this is a somewhat related topic. In specifically the ThoughtWorks technology advisory group called the TAB made a reference to this particular point, and I thought I should just elaborate on this point. So it is quite related. The pictures here, they are kind of relevant to the subject matter here. So you know that in a typical Western classical orchestra, you have a conductor, right, who is in some ways directing the activities of all the musicians. Yeah, they constantly take their cues from the one conductor out there and perform their respective set pieces. So that is even in technical domain, when we talk about orchestrations, that fact remains that there is a central intelligence coordinating the activities of certain downstream systems. Yeah, that is the orchestration. So at runtime there is central intelligence which is dictating things, as opposed to the a choreography kind of approach where yes, a choreographer works with the dancers prior to the performance, so they all know their respective roles, but during the performance there is no central intelligence, right? So again, when we talk in technical terms, the same thing applies, that at runtime there is no central piece of intelligence that is coordinating all the actors. No, the actors kind of look at each other and carry out their own set roles. So when the radar was published some time back, this is what they described under this section: choreography, prefer choreography over orchestration. So integrated business processes span multiple systems. So how should they be coordinated? And the radar suggested that in their experience, centralized orchestration costly to implement and often fail to deliver the promised benefits, which has led us to prefer service choreography as an approach. So what are the promised benefits that we are talking about here? It's mainly this: ability to easily change complex processes. Yeah, once they are already deployed and business changes, you acquire new systems or you want to tweak the process in a certain way, how easily can you change them, right? Traditionally, it has been promised that sophisticated orchestration solutions will allow you to realize this goal, but in practice we have found that to be seldom the case. So now I'll go on to some specific examples and then we'll come back to this topic. So I'm taking an example which is sort of inspired by the environment we have at ThoughtWorks, but it's not the reality of ThoughtWorks. But it just gave me a useful place for coming up with an example. So as you know, for those of you who've been involved with some of recruitment activities, etc., you know that we have a separate recruitment system. There is a separate application where we do time and expenses. We all know what it when we talk about Active Directory login versus RSA login, you know that there is a corporate directory setup, an LDAP sort of database. We use corporate Gmail, and that is a separate system. We update our phone numbers and addresses in yet another small application called as the Global Address Book, GAB. PSMs and other members of the staffing function, they use Jigsaw for project assignments, etc. And PeopleSoft is sort of our employee master. Yeah. So we already have, that we have disparate systems even in an organization of the size of ThoughtWorks. we have disparate systems which have, they did not all start off on the same day, but over time, this is our current reality, part of our current reality. So let's take a very simple case. Of course, in the introduction I talked about complex business processes, but for the sake of this presentation I am going to take a very simple process, but hopefully that will illustrate the point of choreography over orchestration. So let's take the case of a new employee, we make an offer to a candidate, and the candidate accepts the offer and now becomes a new employee within the ThoughtWorks application landscape, right? So you could imagine, this is not reality, but you could imagine that somewhere in the recruitment process there is the final stage of recruitment which says offer accepted, and maybe when there is 2 days to go when the candidate has to join and the candidate confirms that yes, he is going to join on 1st of August. You can imagine there is some sort of a workflow that gets triggered, or maybe somebody presses a button, which kicks off a piece of code, a centralized piece of code somewhere, which makes entries in all these systems, because all these systems need to have, yes?
Yeah, it is a reality actually.
Oh, okay, great. So all these systems need to have some knowledge that there is a new employee, right? And now, even here, what really might happen is, since PeopleSoft is your employee master, you might first make your entry in PeopleSoft, and from there, once that is done, from there take those details and then propagate it to all other systems. But something like this needs to happen, and the orchestration approach of doing this would be to write a central piece of code somewhere which says, okay, go to the first system which is going to function as the system of record, create an employee over there, take the details, and then update all these other systems with a part of the details. Like for example, your role, whether you are a developer or manager, is probably only relevant to Jigsaw and not to anybody else, right? Similarly, your salary is only relevant to PeopleSoft and maybe payroll, but not other systems. So there is typically one way of doing this is you write a central piece of code somewhere. It may be hosted within an ESB, it may be outside, wherever, it may be a composite service somewhere, but one typical approach is to write this central piece of intelligence that knows how to update all of the systems.
That's exactly how we do it in IIMS.
Okay.
So basically what happens when recruitment puts an employee, as soon as they accept offer, the employee record gets in so basically what happens is employee record gets into the PeopleSoft, and 7 days before that view appears on the Oracle PeopleSoft service. And then what happens, you go and actually create users in each of the systems, because they don't need user ID, but they do need username and password, and what exactly you said, right? Jigsaw needs your role. That happens. After that, what happens is each of the system have authorization and access. So authorization is done by CAS. So when CAS comes back to you, the access is granted based on if you part of some group or not. So if we have contractor, then we don't put those contractors into Jigsaw and Gab and TNE groups or mingle groups. So if you look today, if you look in your systems, you have only one username and password across all the systems in ThoughtWorks. We did it like 4 or 5 years back, and that actually helps us to have centralized CAS and user directory. When employee leaves, then again a script runs. So as soon as HR removes you from PeopleSoft, deactivates you, again a script runs and just simply removes you from all the groups and disables your account. Your user records still stay with the system. So that's what we do already.
Okay, great. Thanks for sharing that. So, yeah, that's a typical approach, right? And so now I want to illustrate, contrast this with choreography. I'm coming to that. But what happens is, when a side effect of having a central script, as Ajay mentioned, or in other cases it might be little more, people would call it a separate coordinator service, or a new employee manager class somewhere or within a service, or if you take it even further, there might be actually an ESB with an orchestration sitting there which talks to several systems and all of that, but it's a central piece of intelligence. And one side effect of that is, what if you add a new system, right? We did not have My ThoughtWorks a year back, but even a system like My ThoughtWorks which jive behind the scenes, you need to create a new account over there whenever an employee joins, so that it begins to recognize this employee, right? So the side effect of having central intelligence is that you have to go back, update that, and maybe redeploy it wherever it was, right? As opposed to if you build a more of a pub/sub approach like this, where once it gets updated into the system of record, it just publishes new employee event onto some kind of a queue, and at that point there is no central intelligence which knows which are all the downstream systems that need to be updated. It's just that the downstream systems, according to their needs, they just subscribe onto that, right? And then they update themselves. So in such a scenario, when My ThoughtWorks gets added, it will be an additional listener on this topic or queue or whatever that is, and that would be able to, without any new redeployment or anything, we are bringing in new My ThoughtWorks, so there will be some deployment effort with respect to My ThoughtWorks, but there is no other central piece of intelligence that is getting disturbed in the process, right? So and again, it's this is the earlier one is more of an orchestration approach where there is central intelligence, and this is more of a choreographed approach where there is no central intelligence, but the system of record just knows, okay, interesting events need to be published onto this thing, and all other systems know that, okay, if I am interested in events of this sort, that's where I should go and listen, right? So I am using orchestration and choreography in a somewhat loose sense here. There are some formal specifications like web services choreography, I don't know what the I stands for, there is WSCI and so on. But I think even for the systems that we develop, even if we don't have to go down to the level of the formal specifications, it is useful to compare and contrast these approaches and try to see if we can use this sort of an approach in more places than we currently do. So is it just pub/sub? You got to be careful what you publish. Yeah. When you're saying we are publishing events describe what has already happened. Events should not describe what should happen, right? If it describes what should happen, it's basically a command or a request and not an event, right? But you can put anything onto a queue. A queue is merely an underlying infrastructure. So just the fact that you're using something which enables pub/sub doesn't mean that we've got it right. We've got to be careful about what we are publishing, right? When you just describe what has happened as opposed to what should happen, that very fact is coupling you less to other systems. Yeah? So when we're talking about the main objective here as to being easily able to change complex business processes, one of the key aspects of that is how loosely coupled the systems are, right? So we'll come to other aspects of loose coupling, but even at the level of things that we are publishing, if we restrict ourselves to publishing what has happened as opposed to what should happen, that itself is an aspect of loose coupling.
Problem with is, so now we are coming to profile service in ThoughtWorks IS. The reason we are coming with profile service is that exactly we want to move from orchestration to choreography. And the reason is that when we did orchestration, we had like 4 services. Now we are 8 or 9 or 10 services, and these things will keep going on, right? The problem which we are facing is that the typical use case of contractors versus employee. If we publish it, either we should publish 2 services, which says here are new employee has created and new contractor has created. That actually creates a problem for us because it comes from the same source. So we have to have some central business logic which actually distinguishes between contractor and employees. So it just creates hassle of 2 services. But if we do 1 service, then our application should have that intelligence whether we should choose this guy or not.
Okay, so minor terminology thing. You're not. You don't have to do 2 services. You have to do 2 events. New employee event versus new contractor event, right? And it is the same thing that is publishing. So the thing that is publishing is the same. So even though the source is the same, a source can give rise to multiple different kinds of events, and that's fine. So it's still 1 service the source of the events is a single service, but it's giving rise to multiple events, and it just happens that for different events there are different sets of listeners, or the same listeners respond differently to different events. So is it just good old event driven approach? So some of you, for example, those of you who are programming DOM with JavaScript, or WPF or Swing, the UI is a typical case where you use a lot of event driven approaches, right? But the important thing to note here is, in those cases, the source, whatever is generating the event, does not bother about persisting the event or anything. It just generates an event on the fly, and it doesn't, I mean, some people consume it, some people don't, whatever, right? But here we are talking about a system of, typically there is a system of record which goes through a state change, which it persists, and then it raises an event to let others know that, okay, this thing has happened. Yeah, this is the typical use case in a multiple applications and systems kind of scenario. And the subscribers use part of that event. Whatever, different subscribers are interested in different parts of that event. There might be some overlap, but different subscribers use different parts of that event. And the third point is extremely important. We are talking about decoupled data representations, which means even though the system of record might have, let's say, 4 tables related to employees, that no way reflects in the structure of the message that it publishes. Yeah. So what is published on the wire is totally decoupled from how data is stored internally. And similarly, when these other systems make a copy, partial copy, how they choose to store it internally is again totally up to them, right? So there is unless we get to this stage, we are still not loosely coupled, not loose enough. So we'll see this with a bit of data. Assuming so PeopleSoft is the system of record for most of the employee details here, and you can see that different systems are interested in different parts of that data. So assuming PeopleSoft publishes a new employee event somewhere, then different systems pick and choose what they want from there and make a copy for themselves, but how they store it is up to them. Yeah, whether they are going to add it on to some columns in their existing tables, whether they have a separate table, whatever that is. Yeah, it may or may not be a table, it might be a different kind of data store. So that's what we mean by decoupling the data representations.
So in this case, would you compromise security or let's say access? For example, if you publish all the data and like salary grade is only applicable to PeopleSoft or Jigsaw, okay? So in that case, but the other system who would be listening to that queue would still have access to that data, and so how do you solve this?
Okay, so there is you don't need to compromise. In some cases, data is protected by law. Yeah, so for example, especially in certain maybe Western countries, there might be some regulation by which data like maybe gender and age and maybe salary should actually be protected by regulation itself. In those cases, you can encrypt those pieces of the data and have a public-private key kind of mechanism, so that only the person who has the key for it can decrypt that data. In general, these systems are mostly meant for internal, like all these systems are behind the corporate firewall, most of them. Of course, in some cases we have outsourced and so on, but to the extent that systems are behind the corporate firewall, they are already secure. It's not that somebody has published something and if it's sensitive enough, you can do some amount of encryption, but the mere fact you have published something, you have not published something outside the corporate firewall, it's still within the corporate firewall.
Say the hiring team to know the compensation details of my CEO or anyone employed within, or some maybe the person who takes care of staffing that needn't know my salary, right? So, but if there is a single event publishing that information, there is a problem. So so when you say we can encrypt it, do we encrypt the entire event, or is it possible to even encrypt pieces of data therein?
It is entirely possible to encrypt pieces within, and it is possible to, if things are so sensitive, to publish them as two different events.
Yeah, basically, one of the things we have been doing now I don't know what to do, but what we do usually, the practice is that you need to have certificates for accessing this part of events. So even if you go today to your Active Directory, right, and you can read your employee entry, there are still some fields which you can't yourself read, and they're encrypted for you. So that access control is in place. So because the salary information with recruitment stays till the time they're putting the data into the PeopleSoft. Once they're done, they can't go back and change anything over there. It's like write once, that's all. They can't read anything back. So we do two kinds of things. One is you have write only information where you write and never be able to read that back. So whatever you written, you can't read it. And second is,
Once it has reached the application,
yeah,
I'm talking about the event itself, which is
the application is the application which generates the event, not the application as a Gab or Jigsaw. It's application which actually is source of truth. I'm talking about that master application itself.
Yeah, and maybe we'll explore this a little further offline. So security is and something like a cross-cutting concern in this topic. It's not the core of the topic itself. So, okay. So the interesting thing is, see, when we build systems, right, we typically don't start off with such a varied landscape. You saw already there are some 7-8 systems over here, right? Even when we do systems integration type of projects, we are mostly focused on one core application and some third-party systems, right? And we often have a reluctance to do this sort of copying of data, right? So I'll come to that. Here you can see that different systems maintain copies of the employee data, partial copies, but they do maintain copies. But in the systems that we build, we often shy away from thinking about maintaining copies. Yeah, so I'll come to that, and we'll just park this, and we'll go on to something and come back to that. So when we're talking about service-oriented architectures, there are a couple of basic rules called tenets. One is that boundaries should be explicit. If when you're talking of services, boundaries between services should be explicit, and that services are autonomous. It means that you can potentially reboot a service without affecting other services, right? And yet, a lot of application architectures have something like this kind of pattern, where at the layer of Java or .NET, you have these customer service, order service, fulfillment service, but when it comes to the data store, it's one big data store. As long as it is this way, neither of those constraints are met. Boundaries are not explicit, services are not autonomous, and loose coupling has not been achieved. Yeah. So, and yet, very sadly, this is a very universal anti-pattern, because people are very protective of data and don't want to break up databases, etc. They just write so-called services at layers above, but they ignore the layer at the bottom, and by doing so, you still ended up with not a whole lot of loose coupling. Yeah. So before we ignore the red crosses for a while, but if we were to talk about services that are more loosely coupled than what we have here, each of them should be autonomous in its own respect, explicit boundaries. So you need to have, each service with its own database. So customer service with its own database, physically separate from order service, physically separate from fulfillment service. Now the moment you do that, you are faced with a couple of problems. Services need to talk to each other, like an order might need the customer details of who has placed that order. Fulfillment, in order to make the fulfillment happen, they would need some order details, etc. So either we get into a pattern of request reply between these services. So these services start talking to each other like, okay, get customer details, pass the customer ID, something like this, or get order details, pass the order ID. So there is a lot of chat between services because of the isolation that we have just achieved. That is one side effect often of having explicit boundaries. Or in some cases you might try to avoid that crosstalk between services by having central intelligence. There is something like some architectures, they have what is called, at this level they have what is called as data service. So the customer service knows how to do CRUD on the customer database, and so all these become CRUD data services, and all the interesting business logic goes into a higher level of so-called business logic services, which then talks to the data services, right? That is again a very big anti-pattern of service-oriented architectures, because it's as good as violating encapsulation in the object world, right? We talk about don't have getter setter methods and put the behavior inside the object, and yet we seem to be doing the same thing when it comes to services. Your services are nice, just one big getter setter process, and all the interesting business logic is in some central intelligence outside.
Is there a name for this anti-pattern?
There is a data, this is called as the data services layer anti-pattern. So where there is a layer of services which is only responsible for data, not for behavior, and the behavior is on some sort of a composite service on top, right? And so again, when we try to achieve explicit boundaries, we might run into one of these approaches, which brings its own problems with it. So what do we do? Just like we saw earlier, it's okay to maintain copies of data. So don't ask for this data on demand. So prefer caching over fetch on demand. What you do, whenever there is a customer state change on the customer service, it publishes a customer event. Whoever might need that customer details at a later stage, they are just subscribers. So in the background, they keep themselves updated. So the order database actually maintains a cache of customer data, a partial cache. If customer has a total of 50 fields, maybe the order service is interested in 6 or 7 of those fields. Yeah, maybe the fulfillment service is interested in a bit of customer data and a bit of order data. So it subscribes to both the things. It subscribes to customer event and order event, and it maintains a couple of local caches. These caches are read-only. They are present so that when you want to execute business logic in order, at that point you don't have to do request reply with customer service, or at that point fulfillment does not have to do request reply with order service. So everybody understands, whoever is building the system, that the system of record for customer is the customer service. So any updates will only happen via the customer service interface. It's only to prevent this kind of runtime joins between services that we are maintaining these kind of local copies. Yeah. But it's just that when we come from a different world, right, when we look at the ThoughtWorks systems already in place, that seems very natural. Yeah, time and expense will have some employee records with itself, it will have, right, and all these systems will have, but the system of record is PeopleSoft, and when something changes it has to be propagated. But when we build our own systems, we are a little more reluctant to think in terms of this. And that statement over there, message bus without smarts, is that you might use something like MSMQ or whatever, some kind of message queue out there. You might even use something as simple as an Atom feed. So there is just a HTTP web server running there, and you publish your events in the form of an Atom feed, and the other people just subscribe to it. The rest of the landscape need not have to be a RESTful web services landscape in order for you to think of these notifications in terms of an Atom feed. Yeah, so you could use this much in isolation. Yeah, I just wanted to make one point here. In these kind of things, the problem is because of existing vendor literature. There is a lot of misleading vendor literature. If you go to whatever I recommended IBM patterns or Microsoft patterns, etc. They often don't address these things so much. It's only here and there, and there is this whole tooling aspect, right? So you write your class and put a data contract or something on top, or you run some WSDL to Java and something like that, and you got a service. No, you not got a service. What you got is a web service, maybe a SOAP service. A SOAP service is a technical artifact. It doesn't mean you got a service in the context of a service-oriented architecture. It's like saying I wrote some code in Java, so now I've written object-oriented code. No, you've written code in Java, fine. It may or may not be object-oriented depending on how you have written that code.
So, I had a question.
Yes, please.
So, when we say we want to perfectly decouple two systems, now there might be two systems publishing some information. However, the recipient system might want to receive the events in a particular sequence. So, for example, I have information coming from opportunity information coming from a CRM system, after which I would want some kind of a client principal information therein. Right, so there are maybe two systems or the staffing information on that project coming in, two systems publishing that information.
Okay.
But before I have received the project information, if I were to go and receive that the staffing information, it will be of no use to me. So how do we manage that kind of a scenario?
Okay, so yeah, the moment you start doing things like this, you have to deal with issues like what you brought up. These are, I mean, just like you have a pattern language for object-oriented systems, there is a pattern language that deals with this also. So if you go to eaipatterns.com, there's some. But to briefly answer your question, as long as there is a common business identifier among all these systems, right, and there is a understood sequence that, let's say, opportunity classification comes first and then the next thing comes and then the next thing comes, this is domain knowledge. So as long as the consuming system is aware of the domain knowledge and there is something like a business ID that is part of all these events, right? So it knows that I pulled from this queue or whatever, I got an event of type Y which has a business ID of 22, but I still haven't got X which should actually precede this, right? So that domain knowledge is baked into the consuming system and there is a business ID. So this mechanism that you're seeing is almost like a background continuous thing process. It is not triggered by any user requests or anything, right? This is just keeping on happening on the fly. There might be a user interface associated with these services that people use to actually carry out some business use cases, right? Those things may or may not trigger these events, yeah. So those things are still, it does not imply that the user interaction with the service via the UI, it doesn't imply that interaction is asynchronous. It doesn't imply that. For the most part, it won't. For the most part, it won't. For example, if it requires some kind of information which is not yet being published as an event, right? Or if it requires that while the user is waiting for a response. So we'll come to that. I'm going to say that as much as I'm talking about choreography here, I'm going to say that there is a place for orchestrations, yeah. And that place is when you have when you're exposing some functionality through the UI and a user is waiting for the response, and for that response to happen, you need to coordinate between 2 or 3 services. In those cases, yes, that request response might still kick in, but it will be much less than kicking in for all the cases.
So wouldn't we add some kind of extra complexity in this case?
Okay, great. I have slides addressing each of these.
Okay, but that won't be a request between services. That will be request by the applications which are built on the services.
Yes, that is also correct. So yeah, I have a slide coming up, but I'll just take a small detour. I'll just follow the slide sequence here. So especially people who used ESB products, they would talk about, oh, but distributed transactions. Oh, but we can let after the developers have gone away, the business users can change things. In my experience and opinion, these are distractions. Distributed transactions are a bad idea anyway, and sometimes nowadays, your systems are not even within your corporate firewall; they're outside your corporate firewall. So even if you want that your payment gateway is not interested in being part of your distributed transaction, right? So the preferred technique now is to use compensations. So just replace a credit or a debit with a credit rather than rolling back the debit. And yes, the other thing is a false promise. I have never, even while chatting with others or anything, never seen any system where after the first deployment, subsequent changes did not require developers or technical people. Yeah, it's just that at the level of detail at which these systems are written, even though you practice a lot of domain-driven design and try to have common business vocabulary, etc., it's just that the vocabulary at that level of detail is does not make sense to business users, or they don't want to take responsibility for their changes. It might be as simple as that. Because if you say, okay, make this change in production, and then what if it fails? They want to assign responsibility to IT for that, right? So, okay, thanks. The promised, some of the promises that these costly products make are sort of distractions. So yeah, a place for orchestrations. So if there is a blocking user request which requires us to orchestrate actions across services and get back with a response. A typical case is like at the last stage of your flight booking or something, you have already chosen a seat. So now when you're presenting your credit card details or net banking or whatever, the system behind has to reserve the chosen seat, process the payment, print the ticket, and display a confirmation to a waiting user, right? If you are in a scenario like this, then yes, maybe you have to write an orchestration. Yeah, I'm still, when I'm saying this, it doesn't mean it has to reside within an ESB container or anything. It can be a piece of custom code which has the compensating logics within it. So if you are unable to reserve the chosen seat, then yes, say okay, this seat is no longer available and get back. Or at a certain point, if payment processing failed, then unreserve that seat. So yeah, compensating logic is there. You're not rolling back anything, you're compensating it. But yes, so in a place like this, yes, you might need orchestrations. Yeah, if there is a blocking user request waiting. But even if you account for that, there are still plenty of places where the scenario is not like this, and you could use an alternative approach instead. So coming to this part, last part here, is that the other thing I've realized is that we often, when we think of services, we often think that the UI is necessarily outside the service boundary. Yeah, it need not be so. It need not be so, because when we force ourselves to thinking that the UI is outside the service boundary, that means that all the time there is serialization, deserialization happening between the UI and the service, right? And the surface area of the interface increases dramatically. A surface area of the service means what it is exposed in the service interface. A service, as long if you are able to distinguish that yes, a customer UI, for example, let's take a use case like administration. So in every whatever functionality you provide, there is an admin use case which is only available to the admin users, and there is a regular use case, right? If you take the admin use case, there is some UI for the admin, but that UI can be in process with that service, right? And so this service can expose a web services endpoint as well as a normal web app kind of endpoint for admin use cases, or for even other use cases. So that is referred to as a private interface. So this is a private interface between the service business logic and the UI, which only feeds off that service, right? But there is a public interface which, if other services, like for this case, when you have to write an orchestration, you go through the public interfaces. At that time, you're not, the private interface isn't available to you. You only go through public interfaces, right? And yes, in order to provide a complete application experience, you might have a composite UI, which again feeds off the presentation layer in those services there, right? So approach like this reduces the amount of serialization, deserialization, and the amount of things that you have to expose in the service interface. You can just restrict it to, okay, in my service interface I expose certain coarse-grained public actions which are required by some orchestrations which I have to execute because there is a blocking user request waiting out there. For other cases, you know, this other thing will take care of it. Like for example, if there is a batch kind of process which is specific to the customer service, that will entirely run within that service boundary or within the order boundary, and whatever customer data it needs at that time, that batch would not have to talk to customer service because of this local caching that is already in place. The other problem people have with this kind of explicit boundaries is a reporting kind of use case, because now you have to effectively do a join between these two databases depending on the report, right? So that is a little more tricky to solve, but in systems where maybe partially in a very crude way, you might try to write an orchestration type of logic which essentially performs that join in a Java process space or a .NET process space or a Ruby process space, whatever that is. So it pulls data from here and performs that reporting operation. But if reporting is critical and if these systems are big enough, then very likely you might be able to just use that kind of either that message bus kind of mechanism to build a data warehouse separately. So a data warehouse is basically something that subscribes to all these events and builds a complete set of data for itself to enable reporting. Or you might have, if you're not going through that bus route, you can have other solutions which directly pull data from these databases, but still they are not coupled to the data structures. They may create their own dimensions or whatever, more denormalized structures for the purposes of reporting. And yes, so as you asked, isn't this all too much work? So yes, loose coupling takes effort, but it's a must if systems are to evolve unhindered. And maybe not for every application. This is not the, I'm not recommending this for every, it's a subjective call that you have to take. But the truth is there are a lot of systems out there which are paying a heavy price for not doing this. They've either bought one, some kind of expensive ESB, etc., and they put a lot of logic in there, and the endpoints are basically dumb data services, and there is a lot of logic in there, and it becomes increasingly difficult to maintain it and to change things, all that, and it's expensive also. So if you know that you are in a place where there are a whole bunch of systems and the business is big enough to justify something like this, by all means consider this. So that's all I had. Any other questions?
So going back to my original questions, when you do that, like if you're maintaining a separate service, maintaining a local cache, okay, you might still want to talk to other service. Like what would happen if there's a cache invalidations? Like let's say customer is deleted or customer retailer got updated. Yeah. You have to deal with that.
Yeah, they are all, yes, they, yeah, okay.
Plus, let's say if your cache size grow, you have to evict some customer from the cache and you need it later. You'll have to still go ahead to the customer service to get that customer details.
So evicting, I'm not talking about a LRU type of cache over here, right? So when I say cache and when I show you that thing, this would be just another bunch of tables, right? Assuming that's a RDBMS, which is a subset of the customer tables in that database. So if the customer table, if you have like say 4 or 5 tables related to customer with a total of 40 fields, here you would have maybe one customer table with the 6 or 7 fields that you need over here. Okay. So any updates would also be customer events. So they would also be via events, update event or whatever event, right? And it would require the corresponding changes to be made over here. But that is an offline activity. That is not a activity that happens in, okay, the other point I wanted to mention here is, when you depend on too many request reply kind of interactions between services, it's likely that your application will, lose stability under load, because what's happening is, there are threads blocked here waiting for threads to return from the other customer service. You don't know what is the normal load on the customer service itself, right? So maybe somebody is doing some reporting on the customer service as it is, which has blocked some threads, but order has made a request, it's waiting. And sometimes it's once you start falling for this pattern of it's okay for one service to call another service to service an online request, that service in turn will call some other service, etc. So you end up with a lot of blocked threads very often. And it increases chat, and of course it is like coupling at runtime, right?
So my question is around the initial model that you proposed, where you have a publish subscribe instead of an orchestration. Yeah. So if you would go back to the slide where you have the table of data. Yeah. So the way I see it is a publisher's, let's say, contract of an event would be a superset of everything that these subscribers would want.
Yes.
And if we go on to add another subscriber who needs something in additional to or out of what is already here, then you would end up making change to the contract, like adding it on.
Definitely, yes. But that's, see, that is, if you're saying that you're bringing on a new system, like you added My ThoughtWorks, yeah, and My ThoughtWorks now needs some data from PeopleSoft which is not captured so far yet at all, right? That would need a change in PeopleSoft as well. Yes.
No, my question is around PeopleSoft would already have the data, but it would not be publishing because no one has asked for it.
So what you're publishing is not merely, you don't know in advance who is going to pick what.
Yes.
So you're not simply totaling all the others and publishing that.
Okay.
You're publishing all that you can publish anyway.
So
and letting others pick what they want, subject to the security constraints that she mentioned.
So unless we have the scale of subscribers, that seems to be a little bit of an overhead, don't you think?
Unless you have the scale of subscribers.
Yeah. Let's say if from PeopleSoft or any other system, all you need is the email ID, but the system captures a whole lot of other details which no one ever uses. You will still choose to publish all of them, and isn't it like you are planning too much or something like that? I'm kind of like thinking on those.
Okay, fair enough. So yeah, if you already have a fair idea of the application landscape, and you know that all others are only going to require email ID, so you need to have some idea of, you know, it's a trade-off right now.
Yeah.
So if your message is going to become too huge,
Yes.
and you don't want to put the development effort of publishing that, yeah, you can take a judgment call.
Okay.
But you are aware that yes, if a new system comes which requires a piece of data which is there but I am not publishing, then I have to change this. So that's a call you will have to take on a case-to-case basis.
Okay.